Seth Abelson, the only one maybe in Kitsap County, as far as I know. And I'm with WAVC. So in the next few minutes, we'll talk maritime autonomy. And what I'm going to do is give you a little brief on what WAVC is shortly and give you a picture of what the autonomous maritime autonomous market looks like as a slice, and the reason why perhaps we should pay attention to it as far as Kitsap County is concerned going forward. WAVC is an innovation cluster whose mission is basically to do three things, at least in its initial phase. One is to create a collaboration space where government institutions, whether they're state, federal, or municipal, can collaborate with universities, corporations, and entrepreneurs and invite capitals. The other portion of that mission, of course, is to accelerate innovation insofar as autonomous systems are concerned, to grow the market and the industry in our region. And thirdly, to develop workforce. Workforce is a very key component of what's going on in our world, simply because I think technology is advancing fast enough that our people are staying behind. They find themselves to become now competitive. So this is one of the missions WAVC has to achieve. And if we can do those three things well, there's a very good chance we can get investors, because that's what this is all about. Money tends to follow things that are doing well. And if we can do those things well, there's a very good chance we get investments for our region, that is. Now on to maritime autonomy. Maritime is a very big industry. It's very wide. It's got many components. For the purpose of what we're trying to discuss today, we're talking only about one discipline within maritime, which is autonomy, and that is what is of interest today. If you can think about the word autonomy and maritime, the discussions about autonomy in maritime started sometime in the 70s. Perhaps at the same time you were getting your cruise control in your car. That was the high technology then. And it's kind of crept along all these years to where we're talking today about fully autonomous vessels, which we are not fully there yet, just because technology has been lagging. But advances are now here that this is becoming possible. Most recently, we had the very first transoceanic trip between the Gulf of Mexico and South Korea. It took 33 days. And that was only level 2. It's not fully autonomous. And just for your, description, there are 4 categories of autonomy. Level 1 being basically there's a man on deck piloting the boat. Level 2 is the boat is going, but there's somebody remotely messing with the controls. 3 is some one step maybe above that, and 4 is fully autonomous. So we're not there just yet, but the slice you're looking at right now is what the world market in terms of autonomy looks like for maritime. Better than 50% of all the ships today are remotely are equipped with some degree of autonomy, but remotely controllable. There's only one slice of fully autonomous vessels, just to show you where the market is going and how things are, in real time. Why is this market of interest to us? And these numbers are somewhat conservative. There is a projection that says in the next 5 years, this will become a $12–13 billion market. And this is not the whole maritime. This is just a discipline within maritime that is autonomy. And then again, these are conservative numbers because they only concern surface ships. This data comes from Fortune magazine. And I think they omitted to look at the Undersea, what's going on under the water. But just something to pay attention to. It is suggested that the market will grow at a rate of about 9.3% annually. And that is, software development, tools, machine, people skills, etc. These are the leading companies today dealing with autonomous systems. You will know that these companies are mainly foreign companies. Yes, there are some companies there like Honeywell and BAE Systems, Northrop Grumman, but those are defense contractors. They are not necessarily applying heavily into the commercial world. But 70 to 80% of everything that's happening in the maritime world today is happening outside the United States, mainly in Scandinavia. A little bit more in South Korea as well. But just, something to pay attention to. When you think about autonomy, it's not something to be scared of. There are some advantages to having autonomous systems. For operators, there are some cost advantages to having autonomous systems. They can basically generate revenue and extend either the brand or the market or the product. So I'm not going to run through the list of it, but you can get a picture of what's going on in terms of what happens ashore, what happens on the boat itself. So there are some gains to be had. Of course, autonomy brings anxiety for some people. When you say autonomy, some people think I'm going to lose my job. They're going to close the factory. The man is going to be replaced by the machine, or something to that effect. In some countries, they've actually shown that just because the system becomes autonomous, it doesn't mean people have to lose their jobs. It only means that you can retrain people, reassign work. You can have a captain who was the captain of the boat become the remote operator, etc. But the challenges beyond workforce are also on the technology side. How do you manage things that are disparate in nature, for example, from a technology standpoint, to coexist in the same space? Autonomous vessels, manned vessels, and remote vessels all in the same space, that could be a problem. Obviously, technology can resolve that. There are some things such as legislation that also have to be considered. So, there are many, many other things that cannot be addressed here today, as it's a long list. But there are challenges that have to be attained, but as an industry, it is very viable. The way forward is very promising, just because there is a technology growth, there is money that's being injected into the system. There are people who are very curious about the space. We as a region also would like to grow. That's why WAVC is here. There are companies that are moving to our area just because they too wants to play in the same space. So the way forward, not only it's in capital injection, it's in skill injection, research and development, and your company here locally has a chance to play at the same field. This is about WAV-C mostly. I think this has been said before, but we were funded by a grant from the state of Washington. That's how we got here. Our mission has to do with basically accelerating innovation. But more than that, we have things that we would like to see happen. And some of those are listed here. Basically, we want to see capital come to our region to accompany initiatives that have to do with development of autonomous systems, whether undersea or surface, develop workforce, the next generation, and create communities of people who collaborate on projects and programs. I would like to plug in by saying that you can find information on WAV-C on our website. That's upcoming sometime this month. I think next Thursday it is. All right, and you can find us on LinkedIn, which we're going to be joining very soon. Now, on to introducing my guest, who is a subject matter expert, who's going to help us unravel a little bit of the mysteries on maritime autonomy. I borrow my glasses here. It is my pleasure to introduce Dr. Paulus, PhD. He's the Department Technology Officer for Unmanned and Theater Undersea Warfare System Department at Keyport. He earned his PhD at University of Maryland, and his work focused on measurement of dynamic behavior structures. His career has been involved with developing expertise in measurements and analysis of different systems in dynamic systems, focused on design and implementation and measurement of equipment. His most recent work focused on the use of novel sensors in unique undersea applications. These systems are used for tracking, of undersea vehicles known as UUVs and SUV. In addition, he has the experience of deploying these sensors for multiple types of platform. In 2021, he received the Assistant of Secretary of Navy Research Development and Acquisition Dr. Dolores Eater Top Scientist and Engineer Award for his work on measurement of systems. Please help me welcome Dr. Paulus. All right, so I prepared some questions I'm going to ask Dr. Paulus, and we'll ask those. If we still have time, we may shoot a couple of questions from the audience and go from there. All right. So question one, how has technology evolved in maritime technology since its infancy in the 70s and ushering in the newer class of autonomy systems that we're experiencing today?
Yeah, let's try. Okay, good. We got volume this time. So I think a lot of times when people think of autonomy, they always think of like robots doing their own thing. And I think when we start talking about autonomy, it really started with a lot of scripted types of things. So he actually gave the example, this was not pre-planned, but of cruise control, right? A cruise control is... You want me to go this way? All right, there we go. So the cruise control is like a very primitive form of autonomy, right? Where it just has one set of feedback and one thing that it's supposed to do. As we see things like that evolve, we come up with cruise control that can do motion following, right? So follow a vehicle in front of it. So that's kind of like the next step. As we go beyond that, we start having the systems begin to make more decisions about their environment. So there's kind of two parts of autonomy. There's the one of the brain where it takes and it has to make all these decisions about the things that are coming into it. And then there's also the part which is, as described by my background, is more the sensing side, where you have to actually determine and understand your environment in a digital way that a computer can interact with. So those are kind of the two things that are coming. I'd say that a lot of our stuff has really moved into the prescribed autonomy where you can do and make different decisions, and we're having to add more what ifs, so more scenarios, more different types of perception, things it can think about, things it can do. And you guys may be familiar, but where we're really going is to be able to now, rather than have a programmer or somebody be able to say, hey, here's all the different cases you could look at, we're going to have that vehicle or system go out into its environment, learn about its environment, and be able to identify some things. So like, it's not really a maritime issue, but one of the things that you see with land-based systems is like being able to look at a stop sign, right? So rather than having a programmer try to define a stop sign for the system, we would give the system, say, pictures of stop signs and say, these are all the different ways that stop signs could look. And then now that autonomy system begins to understand how a system or a stop sign would look to itself through its perception and ability, whether that be visual or otherwise.
Most companies are developing autonomous systems today, as I mentioned earlier, are outside the United States. And they seem to be growing faster than our regional companies in terms of product and systems. So how do our local companies compete in the future? Consider that they're kind of falling behind.
So I think that the biggest thing is really having a technical workforce that can solve some of the problems that they're coming up with. A lot of the areas of autonomy have to do with sensing, have to do with programming, and the development of those algorithms. So a lot of those algorithms are complex from a mathematical sense. They're complex from a programming perspective. And then being able to get the advanced sensing and technologies into those algorithms is probably some of the biggest things. A lot of the folks that we have, and we even struggle to hire those sorts of folks within our organization, but that have those backgrounds and skills to readily come in and be able to take what they've learned through education and be able to apply that to those fields. And that stretches all the way from engineers, but it also applies to people trying to utilize and work on the systems themselves, right? So it requires a much more highly educated workforce to be able to take apart, diagnose problems, get the systems to actually work if there's any problems or faults.
There's always a level of fear in our communities when we talk about basically autonomy becoming, whether we're operating a store or a machine. There's a lot of noise on the street about, the arrival of autonomous ships. They're going to wipe out the working class and the captains of the boats and the shops that repair the boats. And what's that all about?
Yeah, so when you talk about fear, I think there's kind of two things. One, there's the fear of loss of job or loss of work. I think I heard it best. I was actually at a DARPA conference recently, and one of the things that they said is that autonomy really allows people to do more, right? And so what ends up happening is those people simply find other forms of work, other aspects, whether that's operating the vehicle, as you mentioned earlier, whether that's doing repair on the vehicles. It really allows a human operator to do more things with less. And that's true, across a wide spectrum of that. We see that. It reminds me sort of the adage, the federal government is a paperless government, right? That's why we have everything electronically. And all that did is it made us able to create more paper faster. And I liken it to this, right? The autonomy is going to have a lot more machines, but those machines are going to have problems, and they're going to need operators. And I think that'll really, the workforce will change, but not go away. I think the other thing, too, that you see when you talk about fear with autonomy is like, what are these systems going to do when they're out there, right? Are they going to run into the pleasure boat that's driving down, out there taking their friend skiing in the canal, right, or something like that? And I think that part of what, as a corporation, as an organization, that we're looking towards is, how do we build in that trust of autonomy? How do we do that through regulation? How do we do that through testing, certification of those programs, to make sure that as we put those things into place, just like we've done with all mechanical systems, no one thinks twice about their cruise control, that it's suddenly going to speed up and they're going to ran into somebody behind them, right? And they don't think, hey, I'm not going to be able to disengage the brake. But that's all an autonomous system that you trust every day that you just don't think about. And so as these autonomous systems develop, and as we get farther and they're more and more complex, I think as we come through that testing and certification of those, to give the users or the people interacting with those autonomous systems confidence in it, will help with that trust factor of that.
Yeah, thank you. One more question here, and then maybe we can open it up for the audience. I showed a slide earlier about projections in terms of numbers. And that was just purely on the commercial side, because Fortune, who's the source for that material, was looking at the maritime surface rather than Undersea. Does this mean anything at all? If you're looking at it from a person from your perspective, does this have any meaning at all?
Yeah, I think so. I think it goes back to the fact that the autonomy can allow us to do more things. And so, for example, if we don't want to have people on a ship gone from their homes for 6 months a year, they can now operate those sorts of vehicles and vessels, from the comfort of their home. We talk about some of the like UAVs that you see in the military, right? Well, a lot of those UAV operators work all day. They fly missions in a foreign country. They leave at 5 o'clock and go to their kid's soccer game, right? And so there's a couple of things to that. One is the fact that, it allows people to be at home, maybe not gone, or to see if that's something that they're looking for. But there's also a psychological aspect of that, especially in the military side, is how do you train someone to be all day looking at pictures of war and then walking out at the end of the day and going home and being with their family and their kids, talking about, something that, well, not their stuff, but what other people are doing, right? And so it can be very difficult as they try to be in two places essentially at the same time, both operating that thing remotely or being part of that, and then also trying to be at home here in the States.
Audience, it's your shot. Questions? I see a hand over there.
Yes, sir. Ships on autonomy in the ocean, it's going to stop the pirates from taking over the ship.
Yeah, so that's a good question. You get into areas like that. Man, they got me on a tight leash up here. It's like they need a dot here so that I know where to stand, right? So I think that that's something that's being worked at. There's different safeguards that you can put in place, whether that's like, a system that stops moving, whether you have manned systems that can come intervene. So there's different things that are done like that. So it depends on, how far away. Like if you're open ocean, that's obviously, a bigger issue than if maybe you're in like an environment here close by, like in the Sound or something like that. But there's ways that you can shut down the systems remotely, potentially, is one of the ways that they've done that. There's ways that you can send help to the vessel if it's in distress via other means, right? So via air or something like that to get their stuff quicker. So those would be a couple ideas on things that you would be able to do. But certainly it has to be a consideration in the overall building of the vessels. Otherwise they would disappear. Yep.
Sorry.
Yeah,
okay,
so-
here comes the mic.
What about some environmental implications for autonomous vehicles?
Could you clarify, like, as far as their impact on the environment, or like things that need to be considered with regard to how they could help the environment?
Yeah, how they can help the environment, or what the impacts are reducing waste, or how they make an impact in general.
Yeah, so that really depends. A lot of times when you have an unmanned system, you can make it smaller and you have less energy in order to transport the humans. Humans are kind of expensive to move around for a lot of things, especially when it comes to construction size of vessels, when it comes to the requirements of the human capacity on board that vessel and other things that you can do for it. So certainly from that perspective, it allows you some flexibility to do different things. Kind of from the other side, as far as helping with the environment, there's a lot of things that we're doing already where we can take things like UAVs and use them to do, remote monitoring of things, or flying like at a low level, or UAVs at like high altitude to do, like, say, surveys of forest regions where we now don't have to cut a road or a path or something through a forest region. We can now fly over it and do that. We do that with satellites. You guys see that. That's similar types of technology that we can implement on a more readily basis with some of the autonomous technology.
Okay, Dave, I'm coming to you with a microphone. Here it comes.
Incoming. So, yeah, I got a question. Seth made a comment about a lot of the autonomy innovation happening in Scandinavia. I wonder if you have any personal observations or experience with that to add.
Yeah, unfortunately, that was actually kind of news to me from an industrial perspective. Since we do mostly defense, a lot of our stuff is focused on the players that are in the U.S. spaces. I can say, generally speaking, I would anticipate that probably has to do with a culture around it that promotes some of the changing of the way we do things and sort of the letting go of the person, right? So there's always this fear that if I let somebody else, or something else in this case, right, do something for me, that it's going to take over or do something I don't want it to. And so I think a lot of that sort of surrounds that autonomy. And then it's just some, I think sometimes there's a little bit of the safety and compliance issues, right? There's a lot of, within our culture, there's a lot of legal requirements that have to be met. And so if your autonomous thing goes off and does something, there's a lot of liability and legals that has to be dealt with that may not be present in some of these other venues that have a little more flexibility to do that.
We've got a question right here, and then was there anything over there? Did I miss anybody? Did I raise it high if I missed it? Okay, right there. So we're going to go here, we're going to go there, and then we're done. All right.
So off of the protecting autonomous vehicles from pirates, what about protecting things like in our ecosystem, orcas or other marine life that are endangered from autonomous vehicles?
Yeah, so like what happens if an autonomous vehicle strikes marine life or doesn't know that there's marine life there? Yeah, so that goes back really to the sensing aspect of it, right? And so I think that part of, as we come through having vehicles be able to answer the what if questions, right? One of the things you can add into that is how they deal with things like marine life or things like that, right? So the first part of that is being able to perceive that the animals are there, right? And the second part is what is the appropriate response, right? And so we have to be able to train, they talk about training the vehicles, but train the autonomy system to make the same decision that we would want it to make, right? So, like for example, the current rule would be like you would not operate your vessel if like an orca was too close to your vessel, right? You would just shut down, you let the orca pass, and then you could start up again. So that'd be one thing. So we want to be sure that the vehicle behaved in the way that we wanted it to. And that's where when we look at stuff like how we teach it, that we want it to be sure that we have it act in ways that are congruent with the values and things that we have as a society so that it goes and does what we want it to do in those situations. So.
This is fascinating. We also use deep reinforcement learning for autonomous control, but for industrial facilities. One of the things we've learned is that You need domain expertise combined with AI to make AI work in the real world. And that intersection is quite rare. So my question for you is, where do you find your talent?
Wait, that's not a fair question. So a lot of the talent we end up having to grow, right? And we kind of grow that two ways, like you said. If we're trying to learn the subject matter of like the machine learning or AI deep learning, or the technical side of the sensing and that, how those intersect. Oftentimes what we end up is finding one half of that talent and trying to grow the other half into what they're doing, I think is probably the thing that happens the most. Sometimes we find those silver bullets, and that's great, but generally we have to grow one side or the other.
All right, folks, thank you very much. If you have questions, we are here. We are reachable by email, website, phones, in person, walking down the street, whatever we meet. So thank you very much for your time, and thank you, Dr. Paulus, for being here. And well, thank you.